Hello friends, I'm working on my next how-to video. I'm working on this for kindergarten, but it'll really be a good video for kindergarten through first grade. The focus of this video is to teach how to find the missing part. This is a huge idea in kindergarten and first grade. It goes under them understanding part-whole relationships, which is a prerequisite to really truly understanding computation. So in our Virginia standards, it helps build computational fluency. These are the exact standards for Virginia, the SOLs. So for kindergarten, it's K4A and K4B, and kindergarten students are expected to recognize and describe with fluency. That means flexibly, accurately, and efficiently part-whole relationships for numbers up to 5, and they are supposed to be able to investigate and describe part-whole relationships for numbers up to 10. They're not required to do that with fluency, but it's expected that they are working on those numbers to 10 and developing some strategies for those. And then as you can see how this works as it vertically grows in first grade. In first grade, students are then expected to recognize and describe with fluency those part-whole relationships up to 10, and that's going to transfer to them demonstrating fluency with addition and subtraction facts to 10. And just to let you guys know, when we're talking about addition and subtraction facts to 10, this can look a variety of ways. All of these are examples of fair game questions for addition and subtraction to 10 that would match a model where you know the whole is 7 and one part is 5. So you could do 7 minus 5 is the same as what? What number is the same as 7 minus 5? We want our students to know that this equal sign does not mean the answer. It means that whatever is on this side of the equation is balanced by whatever is on this side of the equation. So any of these are fair game, but a lot of times parents don't realize or understand that it's important and meaningful to put the missing part on the opposite side of what you may have normally seen it as. So some number is the same as 5 and 2, 5 plus 2, 2, and what number is the same as 7? 7 is the same as some number plus 2 more. This is the hardest one, that's why I put it at the bottom. 2 is the same as some number minus 5. This problem right here just goes to show you why this is super duper important, because if students, the only way they can figure this out is really understanding that subtraction is whole minus part, and that gives you a part. So then they would have to then use the inverse relationships and put 5 and 2 back together to figure out that that's 7. So that's a pretty hard first grade one, but first graders would see all of these. So that's where we're trying to get them to. Those are the aligning standards. Let's talk about some ways that we can practice these skills. All right, there's so many ways to do this. I'm not even showing you all the ways. I'm just going to show you some of the ways, because honestly, our students need a lot of practice with this in the primary grades, and you can do this even up into the upper grades, just the numbers get more complex. So the first game I'm going to show you is Snap It, then I got Hide It, a Domino Sort and Cover. I'll show you missing part flip cards, and a part-whole organizer. All right, so Snap It, we play at school with Unifix cubes. So you can have any number. So this is 5 Unifix cubes. So we'll say that our whole is 5, and we'll show the students that we have 5. And then we would put these cubes behind our back, and we would snap it and just show them part. So if I show you 3 and I'm holding the other part behind my back, then you have to figure out what is the other part behind my back. So students can either think 3 and count on 3, 4, 5. So it would be 2 would be hiding, or they can use their fingers. 3 in my head, 4, 5. I would need 2 more. Or they could start with that whole of 5. Say if I had 5, but now I only see 3, I must have taken away 2. Or I can say if I have 5, but I take away the part that I see, the 3, there must be 2 behind her back. Those are all different ways that you can think about finding the missing part just for this one thing, and students do need to experience all of them, because we want them to use strategies that make sense to them. So that's how you would play Snap It. If you don't have things that will snap together, you can do this with Legos, or if you have Unifix cubes you can, but I know most families don't have Unifix cubes at home. But you can Another version of it is you can do hide it, or some teachers like to call this bears in the cave, especially if they use those little counting bears. But you can really use any one-to-one manipulative. So I have a couple examples here. So you could use pasta, dry pasta. You could use goldfish, or if you really want to motivate your students and you don't care as much about their health, you can use M&Ms. And since blue is my favorite, I use blue M&Ms. So let's say I was going to play hide it, okay? So here I'll say, how much do you see? They might say, I see 2 and 2 is 4. They might count 1, 2, 3, 4. I hope that they're kind of subitizing at this point. So if they see 4 and then I tell them close your eyes, I'm going to hide some, okay? We know there's 4 under there. And then I'm just going to say, okay, how much do you see? 1. How much is still under there? So again, they need to either figure out 1 and 2, 3, 4, 3 more would get me up to 4, or they could start with that hole that I had, which was 4, take off the part that I see is 3, or they could say, how many do I need to take away to only have 1 left? I will have to take away 3. So then they would know that underneath there I would have 3. Okay, so that is hide it. And if you do bears in the cave, you just name whatever manipulative you're using bears. You can say there's 4 bears. You always want to tell them what is the hole. There's 4 bears. All right, close your eyes. Let me see if I can hide. The bears are in the cave. And then, can you tell me how many bears are in the cave? So if 2 are out, then 2 must be in. And then they can check. Okay, so that's hide it or bears in the cave. Another example of something that you can do if you have dominoes around your house, because some people do. Dominoes are great for part-whole relationships. I'm just going to put some here. These have a little bigger numbers on it, but some of them are smaller. I have students sort dominoes a lot. As you can see, dominoes have 2 parts and a whole. Each one does. So 6 and 1 is 7. So your whole would be 7. One part is 6 and the other part is 1. So that's 7, right? Okay. But then let's see, 3 and 1 more, that's 4. 6 and 6 is 12. I got 2, 5 and 5 is 10. 2 and 0 is 2. 6 and 5 would be 11. But as you come out and you have more cards, more dominoes, you might have a domino that looks like this, 2 and 2. That would also go under 4. Let's see what else I got. 5 and 2, that would also go under 7. So let's just kind of focus on these relationships under 10 for now. So once you have students sort, you know, you can use these dominoes and let them know whatever the whole is. So say I'm working on the 7s. I'm going to tell them up front, okay, there's 7 dots on my domino. And then I'm going to hide one side. There's 7 on my domino. What's under my finger? So they have to think 1 and how much more gets you to 7, or 7 minus 1 would get you 6. And then they can see that other part there. Same thing. Tell them my whole is 7. What's hiding? So if I have 5, 5, 6, 7, that would be 2 more. Or I can think 7, take off 5, would leave me with 2. Okay? This domino matches this organizer here. So the whole is 7. The part that I saw was 5, and the other part must be 2. This domino also matches number sentences 7 minus 5 would be 2. You could also see this as 7 minus 2 would be 5. You could also see this as 5 and 2. And I'm just going to write it on this side because I told you guys it could be on either side. Or 2 and 5 is 7. This domino could be represented by any of these number sentences. Alright, so I showed you the domino sort, and I actually showed you the part-whole organizer here. So they get to the point where we just give them these organizers and we can ask them what's the missing part here. And the other version of that is these missing part flip cards that you could make on your own at home. They don't have to be as official looking as mine. I just happened to bring mine home from school before school got locked down. but I'll show you an example. If you want these, I can email them to you. You just shoot me a message. But they have plenty of them on Teacher Pay Teachers. I bet there's many of them are even free at this point. But this is how the flip cards work. You have a hole. Like here, my hole is 10. What part do I see? 6 and one more 7. So I need to think what's underneath the flap. So 7 and how much more gets me to 10. So I can think 7, 8, 9, 10. I would need 3 more. I can count on to figure that out. Or I can start with 10 on my fingers and take away 7, and that would leave me with 3. So usually as I'm practicing with students, I am careful about the progression of numbers that I give them. I start with the smaller numbers first, like something more like this, and then I build up to the larger numbers. I do want students to be fluent in their combinations up to 5, and then I usually jump to 10 next, just because partners of 10 is so important for when they start doing computation to 20. But then after, and they usually get 10 quicker because they have 10 fingers and there's no extra fingers. But after 10, I usually go back and do 6, 7, 8, and 9. And those on 6, 7, 8, and 9, that's where you're really going to see students that instead of just being able to memorize those combinations, because sometimes they can just memorize. A lot of kids are good memorizers and they can memorize the combinations. But on something like 9, if you have 9 fingers and you have 5, some kids get messed up. What are they going to do with that extra finger that's down? So on a number like 6, 7, 8, or 9, that's when it's really helpful to have a strategy, whether that is counting up from the part that you know, so 5, 6, 7, 8, 9, or starting with 9 and then taking off 5, and you would be left with 4. Okay, so this used to all just be on one little Word document. I made these myself, but you can make these with strips of paper at your house. You can use the dots, or you can actually write numbers in there depending on where your student is at in this standard. But these are all different ways that you can practice this finding the missing part thinking. This finding the missing part thinking is huge because this helps them connect addition to subtraction. Subtraction is very hard for students in the beginning, and it's not just take away, it's also comparison, it's also adding up. So we really want them to be able to understand the relationship between addition and subtraction, and doing all of these types of activities are the things that are going to help them build that understanding. All right, thanks for watching.